Hello everyone. In this lecture, we are going to have a brief overview of the different construction activities and their scheduling, and also about resource management in a construction site. If we look at the construction activities, for example, in a building construction project, then they will be something like this, where first we'll have to clear the site of all the debris and trees and other material. Then landfill may be required if there are some depressions. Leveling is also required. Then we'll go for excavation for the footings, then construction of columns, beams, walls, plastering, doors and windows, floor finishing, painting. So in this way, the things will progress with a logical sequence. Now, to have a better idea of what follows what, it's this kind of a bar chart or Gantt chart is used. It is called Gantt chart because an engineer called Henry Gantt first used this kind of a technique. So it's a very simple technique actually. If you look at it, at first we'll have clearing of site, which is the first and foremost activity, and the horizontal length of this bar diagram will give you the duration. Suppose in this case it is 2 days. After that, after this activity is completed, we can go for landfill and leveling. So that will be again suppose taking 4 days and so on. And after that, we'll go for all the other activities in a proper sequence: excavation, footings, then columns, then plinth wall, then filling up of the foundation, then beams and slabs, then partition walls, plastering, doors and windows. And in this way, all these activities will be scheduled. However, here it looks very simple, but all these activities are not one single activity, and they may comprise of several other activities. And if we look at all these activities in a higher resolution, then we'll see something like this. So first we'll have to clear the site. It will take some time. Then earth fill and leveling of site. After the excavation, for the footing is completed, we'll have to go for soling, that is brick soling, and PCC layering of the footing, the bottom of those pits. So that should take a small time. After that, we can go for cutting and fabrication of footing and column reinforcements. But since this activity is not dependent on the excavation part and the soling part, that means we can start it right after we have a proper clean site. That means right after completion of this activity, we can start this fabrication of reinforcements. So this can go simultaneously with these two activities. Now, how much time all these activities will take will depend on how much resource you deploy. However, let's, for example, in this case, assume that we have completed all these activities here on, suppose, the 15th or 17th day or whatever the number be. Now, we can see that since the reinforcement fabrication has taken so much long time, these two activities could have been started 1 or 2 days later than we have started here. So that means the total duration of the project will be depending on this activity, that is clearing of site, earth filling, and fabrication of reinforcements. And these two activities in between can have a little bit of floating room, and technically also that is called float. We'll learn about it later on. After that, we'll go for casting of footing when all these activities are completed. After that, we'll prepare the shuttering for the columns. Then we'll cast the columns, and after that, we'll remove the shuttering for the columns. Then we'll go for brickwork for the plinth level. And brickwork for plinth level cannot be started unless we remove the shuttering for the columns. because the brick will have to be connected with the concrete of the column. And after that, we'll have to fill up the plinth level. That is, if this is the plinth level, these will be brick walls. There will be columns here at all these corners, and we'll have to fill up this whole portion with soil and also do some compaction. After this is completed, we can go for beams and slabs. Now, all this time, we can also carry out another activity, which is the carpentry. That is the preparation of the door and window frames. So this activity, depending on how much time it takes, it is not dependent on all these activities, and it is only dependent on this clearing of site. That means if we have a clear site, clear workplace, we can start the carpentry work. So now we have anticipated that the carpentry work should not take much time, so we have not started right away, but we have given it some room. That is, we have started it a little bit later. After that, we'll go for shuttering for beams and slabs. It should take some time, maybe a week. After that, reinforcement for beam and slabs will be prepared. Now, in this case, reinforcement for beam and slabs will not be prepared until we have the shuttering in place. That means we'll have this kind of shuttering boards placed with proper format, with room for the beams as well. And after this is complete, we'll place all the reinforcement bars here for the slab and also for the beams. After this is completed, we'll go for casting of beam and slabs. And in most cases, the casting of beam and slab is done monolithically and therefore on the same day. So casting of beam and slab generally takes a very short time, maybe 1 or 2 days. If it's a very large slab, we may do it over 3 or 4 days. But after that, we'll have to wait for 20 or 21 days. So that means during whole this period, no other work can be carried out. So it's advisable that you can engage all those workers for some other project or maybe some other part of the work if available. After this shuttering can be removed, it should not take much time again. It will be a matter of 1 or 2 days only. Then we'll go for the brickwork for partition walls. Now, brickwork for partition wall can be completed over suppose a few days, and after that fitting of doors and windows should come. But fitting of doors and windows generally go simultaneously with the brickwork. That means if you have this much brickwork done, at the same time you fit the door frames here, and therefore the doors and windows will have to be ready, the frames at least, not the panels. The panels can be fitted later on, but the frames or the chokats of doors and windows will have to be prepared by the time we start our brickwork. So this fitting of doors and windows will have to be completed along with the brickwork part, and after that we'll go for plastering. So the carpentry work will have to complete right before we start our brickwork. So this is the maximum time by which this door and window frames will have to be ready. Actually, this can go slightly here because for the first part of the brickwork, at least for the bottom part, we are not bothered about the doors and window frames. So they can be slightly delayed till the masons actually ask for the frames. If it is not ready, then they'll have to simply wait and the total duration of the project will be affected. So this is how all these activities are scheduled. Now this kind of a graphical representation using a Gantt chart or a bar chart is helpful in understanding the duration, and it's also easy to read, easy to prepare as well, but it also has some advantages and disadvantages. So it is easy to understand and easy to prepare, but the relationship between various activities is not very clear. For example, if we look at this last activity, so this last activity will be, it may be dependent on this activity. That means it is, we can assume or we can guess that since it has started on the after completion of this activity, that means it must be dependent on this activity. But it could also be dependent on this activity, but this activity is already completed. So in this kind of a representation, it is not clear whether this activity is dependent on this activity or not. In some modern softwares where this kind of bar charts are prepared automatically after you feed all the data, they do have arrangement for preparing this kind of arrows to show these interrelationships. That means if one arrow comes from this activity and meets here, that means this activity is dependent on this. But it is easy for the software to understand, but using by human eyes, this kind of complex network is difficult to understand, and all these arrows will intersect each other, so it becomes difficult to read. So for that, we have some other methods, other techniques, which is called an activity network. So in activity network, what we do is we use some nodes and arrows. So this node will lead to another node. So this node represents, suppose, the beginning of brickwork, and this node represents the end of brickwork. And this arrow represents the actual brickwork activity. So here we'll have to write in numbers inside a box, suppose how many days or how many weeks it has taken, suppose 7 days. So after brickwork, we'll go for plastering. So this arrow represents the plastering work, and this node represents beginning of plastering work, and this represents end of plastering work. Now you see this same node represents end of brickwork and beginning of plastering. So this is some technique which we can use. And if there is some other activity which is also dependent on the brickwork, then that will also start from the end of brickwork and lead somewhere else. So this is one way of representing these activities and their relationship. There is another way, which is where the nodes represent the activity. That means this whole node is, suppose, brickwork, and this node is plastering, and the arrow doesn't represent the activity itself, it only represents the interrelationship, and whatever is the duration will be written inside this circle, or it may be a rectangle as well, depends on what kind of convention you follow. So here we may have to write what is the beginning date, suppose 7th of some month, and this is suppose 15th of some month, and so on. So we'll discuss all these techniques later on in our subsequent lectures. So for now, we just understand that there are different ways to represent all these activities and prepare the schedule. and they all have their own merits and demerits. Now let's get a little backwards, because all these um, graphical representations will depend on a list of activities. So in the list of activities, we will have to describe what all these activities are. So in the first column, we simply are listing all these activities, and the second column we are writing about the predecessor activity. So the predecessor activity is the activity which is required to be completed before we start the given activity. For example, earth fill and leveling of site can start only after we complete the clearing of the site or cleaning up of the site. But the cleaning of the site is not dependent on any other activity, because it is the first and foremost activity, and so on. So you can see the relationship between all these activities. Here a particular example, that is casting of footing. The casting of footing will depend on excavation for the footings, then soling and PCC layering at the bottom of those pits that we have dug, and cutting and fabrication of footing and column reinforcement. So when all these three activities are completed, then only we can go for casting of footings. But here one thing is actually unnecessary. For example, soling and PCC work can be, it's mandatory for casting of footing, but it can be done only when excavation for footing is already done, and which is already shown in this activity. That is, soling and PCC layering of footing is already dependent on excavation for footings. So in casting of footings, we don't have to write this excavation of footings, because it is anyway already completed to complete the immediate previous activity, which is soling and PCC layering. So therefore, this is unnecessary information and will be only requiring these two activities. So this is how all this list is prepared, and it is very important that you have proper knowledge of the construction practices and also very good knowledge of civil engineering construction activities. Now, a few tips or things to be kept in mind. They are not in very any particular order. For example, if we are dealing with a multi-story building, then shuttering works for the, suppose the slabs, can be used for multiple floors, and generally many contractors do not have their own shuttering, so they bring them on rent. So when you are bringing some shuttering boards and poles and columns for one slab, suppose the first floor slab, after it is removed, suppose after 21 or 28 days, then you can immediately start shuttering for the next floor, and on that floor, if you use the same shuttering material or the same shuttering boards and poles and etc., so in that case you don't have to bear the transportation cost, because the vendor who provided you the shuttering boards will have to bring it, have to return it back, then again provide it to you after some days. So it's better to cast all the slabs as quickly as possible, so that the shuttering work, the same shuttering material can be used for all of them. In case of multi-story buildings, again, if we have completed, suppose, a several number of floors, in different floors different activities can go on simultaneously. Suppose on the ground floor you have already completed brickwork, plaster and painting and flooring are already completed, so you can go for plumbing or wiring in this floor. On the upper floor we can go for, suppose, painting. On the floor above that we can start plastering, and on the floor above that we can start our brickwork. So this can be managed if you plan properly. But just because we can do it like this doesn't always mean that we should do it like this, and that's because of some management difficulties. For example, painting for walls at 3 different floors, it's a simple job. You only have to deal with one type of laborers, that means the painters. So it is easy to manage, but if you deal with several works on different floors, for example, on one floor you have painting, on one floor you have plastering, on one floor you have brickwork, add to that plumbing and wiring at different other floors, so it becomes very difficult to manage different types of works, different types of laborers, and generally it is not advisable. However, if you have the capability of managing all these works together, then it's up to you whether you go for this model or this mode of management. It doesn't mean that this mode of management doesn't have any problems, because if you want to go for painting at, suppose, 10 different floors in a 10 stories buildings, suppose you have completed all the other activities and only painting is left, now you want to go for painting at 10 floors simultaneously. But the problem is, can we get enough number of painters to carry out these activities simultaneously? If we have enough number of painters to carry out this activity only for 3 floors, then it is better to do it like that and carry out some other activities in the remaining floors. So this kind of management will have to be done, and with experience you can always figure out which works are to be preferred, whether this model or this model is to be preferred, and so on. Now let's come to resource allocation or resource management. So the duration of an activity generally depends on resource availability. Resource in this case means material, manpower, machinery, etc. Generally, in most cases, greater resource deployment reduces duration. If you employ 10 people, they will be doing it faster than what 5 people could do. But there is a catch here. The relationship between the resource deployed and duration depends on the type of work. For example, let's take the first example where we have a very long wall which is to be constructed. Now, if we only use a small number of laborers, they will be taking some time. But in this case, since work can be simultaneously carried out at different sections of the wall, so we can employ a large number of people and speed up the whole process. But the same cannot be done if instead of length of the wall, the height of the wall is more. So for this kind of an example, you cannot construct this part of the wall before you construct this part of the wall. So therefore, in this case, this model will not be valid. Another point is that excessive resource deployment becomes counterproductive. Just because 10 people are doing it in 10 days, you cannot employ 1,000 people to do it in 2 or 3 hours. It's not possible, because if you excessively deploy these resources, then the coordination will be disturbed, because there will be too many people in a very tight space and the work will not be efficient, and instead it may be even counterproductive. And finally, just 2 points I want to mention, that is, the relation between resource and productivity may not always be linear, which we have already seen in case of the previous example. That means just increasing the number of laborers, you cannot always decrease the duration. Another example may be, suppose you are employing a laborer, to clean up a number of rocks which are to be cleared up from the site. Now, if one laborer takes 2 days to clear up all these rocks, then 2 laborers should be able to do it in 1 day. But it's not always that simple. Suppose we have a few very large rocks and 1 or 2 laborers may not even be able to move them. So in that case, just because you have employed 2 laborers, if one laborer cannot move it and 2 laborers cannot move it, in that case the productivity is 0. The moment you increase it to suppose 4 laborers, they can easily move these rocks within suppose 1 hour. So it is required to remember that sometimes for some activities a minimum number of resource deployment is always necessary. Some works cannot be done by suppose 2 people, 4 people is always necessary, and so on. The final point I want to mention is the allocation of resources should not fluctuate very rapidly over time. That means on one day, if you have employed 20 laborers, the next day it should not go up to 100 laborers, because it causes lots of disturbance at the work site, and also you'll have to deal with fooding, lodging, and sanitation facilities for all these workers. So if you have suppose a mess running for the food, or the nearby stalls will be able to accommodate 20 or 30 workers on one day. Suddenly, if one day you bring in 100 laborers, 100 workers, in that case they will not be able to get their food on time. There will be problems regarding sanitation, urinals, and so on, and therefore it is advisable that you increase the labor force gradually, and when you decrease it, then also it has to be done gradually, because many of these laborers are not paid salary but daily wage, and therefore if they are called in for one day, then again they're not called for next 2 days, again you call them for the day after that, it becomes unreliable and they would not be willing to work with you if you are a contractor suppose, and they will look somewhere else. It is not a problem if jobs are scarce, then they will be willing to come for any kind of job, but when there are other options, they will definitely go for some other work site where their requirement is regular. That means they will be called for a week or continuous 2 or 3 weeks, so that they can be sure that they will be earning those wages for a significant amount of time. So we'll stop our discussion for this introductory lecture here. Now we'll learn about all these things. We've just now learned what to be done, but how these things are done, and when the numbers increase, it becomes very difficult to just do simple calculations, and we may have to learn some proper techniques to deal with all these problems. So that's all for this lecture. Thank you.